There we go. So now we're recording. So guys, day 3, right? Can you believe it? We are now 3 days into the year, and I'm happy to report that this is the last day where we are going to do numeracy stuff in this class. Oh, thank goodness. We're ready to move on. But again, guys, let me just say, I appreciate your patience if I've been trying your patience. And I know for some of you, especially those of you that have been taking physics, you're just hanging on going, this had better change because this feels a lot like what we did last year in physics. Guys, if that's the case, thank you, and it's going to feel a lot different starting Thursday. But understand, in every year we talk about just skipping over this, but we also need to appreciate that some people haven't done physics, and frankly, some of you just need a little refresher. So again, if this has just been you going, another day of this and I'm going to die, thank you. And I think I guarantee you, I don't care who you are or where you come from, guys, you're all going to glean something from what we're going to do today. So guys, today what we're going to do, obviously the topic for your notes is graphing. The date is the 25th of August. And guys, what we're going to do today is we're now going to take the third step, right? Day 1, besides watching horrible home videos of me sweating and riding my bike, we also talked about some fundamental numeracy stuff, rounding, scientific notation, things like that. Then guys, last time we talked about the types of data that we're going to collect. What were those 2 types of data, by the way? Qualitative and quantitative. And then we talked about how we communicate the quality and accuracy of quantitative data. You guys notice that I'm reviewing right now because that helps you learn. So guys, we talked about the quality of quantitative data, and we used the term accurate and precise. Remember, precise means well grouped and accurate means correct. And then we talked about how do we communicate accuracy. And that's where significant digits became a part of the conversation. Well, guys, now to round out this conversation, here's what we're going to do. Okay, we understand we're collecting data. We understand that a lot of that data is going to be quantitative data. But guys, the question then is this: what are we going to do with that data? And the answer many times is this: we're going to take that data and we're going to generate graphs. Now, guys, here's the problem. I would propose to you that we have crippled you as people. And when I say we, I mean our education system, specifically the math department. We have crippled you, seriously, in your ability to do this, because I guarantee you that most of you with your super sexy TI graphing calculators could whip that sucker out and there's your graph. But guys, when I hand you paper and pencil and say, let's draw a graph, you would be amazed, frankly, at some of the stuff that I get back. And this is from moderately intelligent people that actually don't know how to analyze and process data. So guys, here's what we're, at least graphically. So guys, what we're going to do today is this. First of all, we're going to talk about why do we even do this? Why do we waste the paper and the time to draw graphs? Then, guys, what I'm going to do is I'm going to make you an intelligent consumer of graphs. And we're going to talk about what are the different types of graphs you have at your disposal and when will you intelligently employ those types. Then what I'm going to do is I'm going to give you some hints on how to do this better, and then we're going to actually electronically graph some data. Then once you all say that you understand how to go through this process, I'm going to actually show you negative examples of, frankly, some of the garbage that I receive, and you guys are going to pick it apart and go, man, that's trash, that's wrong, let's fix it. And then, guys, when we're done with that, you're going to have some time to work on homework and do your own. You ready to go? Okay, so guys, thought number 1 is this: why on earth do we draw graphs in the first place? And the obvious answer is because it makes people like this happy. You guys all know him, right? Charles David Keeling. Interestingly, he hasn't won a Nobel Prize yet, but I think that's going to change eventually. Do any of you know why this guy has the little ribbon around his neck? It's not a Nobel, but do you know what he's all about? You ready? This fine fellow, Charles David Keeling, is all about data that looks like this. And of course, you guys can all look at this, and because you're all bright young students, you can look at this data and you can go, Yeah, I get that. It all makes sense, right? No? But what if I told you this? What if I took this data and I graphed it for you? Guys, that data set that I showed you previously is actually the data that Charles Keeling based the theory of global warming upon. Charles Keeling is actually the scientist that connected the fact that the temperature of our planet is actually going up in lockstep with the concentration of the carbon dioxide in our atmosphere, the greenhouse effect. He's the guy that proposed the greenhouse effect. Now, guys, the problem is this. I don't care how many PhDs you have after your name. If this is your data, you're stuck. There's no way for you to make sense of this. I don't care how bright you are. He would have never teased that relationship out of his data had he not, frankly, had a graduate student graph it, because professors don't draw their own graphs, and come up with this. Guys, because now we can see it. Because what we have here is carbon dioxide concentrations and then actually temperature in red graphed over that. This is the cyclic increase in temperature. And guys, what we end up seeing is that in fact, as this is going up, the temperatures have actually increased in lockstep with the concentration of carbon dioxide. Now this guy's no idiot. He decided if I'm gonna go measure carbon dioxide concentrations, I'm going to Hawaii. But, guys, this is the data that actually led to this idea of global warming being tied to the greenhouse effect in carbon dioxide. So clearly stuff like this has a purpose. So your goal then, guys, is to be able to do things like this and take data sets, data you've collected, and represent it intelligently. So here's where we're going to get started. First of all, we need some vocabulary. This needs to be in your notes. So guys, as we think about this, there's actually two terms that I just need to lay out for you right now. And I'll be honest with you, this is harder than it seems. There are times when even I struggle with this. Believe me, I am in no way the pinnacle of intelligence, even in this room. But guys, I've been doing this for a long time. And even as I think about the terms independent and dependent variable, there are times where I've got to step back and go, oh man, what do those mean? So let me define them for you right now. When you're graphing data, many times you're looking at relationships. And when you talk about graphical relationships, one of the things that you're going to have to be able to nail down is what are you controlling and what are you watching change as a result? And guys, we give those names. The independent variable is the thing that you are controlling. The dependent variable is the thing that you're watching change. And you know what? I want to add something to this. Here's an easy way to remember that relationship. Sorry, this is going to seem corny, but it works. Come on. Here we go. So do you guys struggle typing in public? Seriously, I get all nervous. The dependent variable, ready? Depends on the depend. I quit. I should just copy and paste. I can't even type now. I'm going to go home. Is that right? Independent. All right, I'm just going to click on it and do autocorrect. Good heavens. All right, there we go. So guys, if you want a way to think about this, and I'm going to move this up. If you want a way to think about this, frankly, this is what I fall back on when I can't remember which is which. The dependent variable depends on the independent variable. And I know that that seems obvious, but I swear to you, when you get into the middle of this, you're going to go, whoa, which is which? And if you can construct a sentence like this and play with the direction that you put the variables, I promise you this will help. And I'll do that with you in a minute to help you understand. So guys, these are two terms that you just need to know. I don't expect you to understand them right now, but we are going to be using them in a minute, and I wanted to get them in front of you now. You good? You're okay? All right. And I don't mean are you good in terms of do you understand? I mean, do you at least have it written down? You're okay? Okay. All right. So guys, here's where we're going to start. We'll start the concept. So when we're graphing data, we need to understand that we have a toolbox, if you will. We have got some, and you don't need to write this down, we'll come back to it in a minute. There are some types of graphs that we are going to utilize in this class. In biology, you do a lot of pie charts, because biologists like to look at parts of a whole. We don't do that. In this class, there are actually three types of graphs that you'll be utilizing. The first one is what is called a line graph. And I think that you've probably seen examples of that. Guys, line graphs are really good at describing relationships. So as this changes, what happens to this? Clearly, guys, as whatever this is, follow the laser, whatever this is, as this gets bigger, what happens to this? Does it get bigger or smaller? Smaller, because this has got a negative slope, right? So if nothing else, we know by looking at this that as this gets bigger, this gets smaller because the slope goes down with a couple little exceptions, but the general trend is down. Those are line graphs. They describe relationships. Then, guys, we have bar graphs. Bar graphs describe populations. So they talk about how many people are this, how many people are this, how many people are that. So bar graphs talk about population distributions. And then, guys, finally, XY scatter plots also talk about relationships, but places where there is not necessarily a cause and effect, meaning that you could switch these. And we'll talk about that more in a second. But if nothing else, guys, recognize these by sight. Line graphs, bar graphs, scatter plots. You good? Okay, now let's start taking notes. Let's go into this a little more deeply. So guys, when you're doing a graph, and you don't need to write this down, it's self-apparent, but guys, the bottom line is this. You always collect the data first and choose the graph second. So if you need to make and this is going to be in the homework, you've got to justify your choices. Guys, when you choose a graph type, it's got to be done intelligently. So let me give you the tools to do that. Ready? First of all, line graphs. Get this in your notes. So guys, what are line graphs good for? The answer is this. Line graphs are best to show a relationship. Here's the terms you just learned, right? Line graphs are best to show a relationship between the dependent and independent variables. These are cause and effect relationships. As we change the independent variable, what change does that cause in the dependent variable? So these are good for cause and effect relationships where we have an independent and a dependent variable. An example of that would be something like this, where we're adding energy to water and its temperature goes up until it starts to boil. So adding energy is causing the temperature to go up. But guys, causing the temperature to go up doesn't add energy. It doesn't go the other way. When we add energy to water, like on a stove or a burner, when we add energy to water, the temperature goes up. But the other is not necessarily true. When the temperature goes up, that doesn't necessarily mean we've got a source of energy. So one can cause the other, but not vice versa. So guys, the bottom line then is this. When we do these graphs, the independent variable is normally on the x-axis and the dependent variable goes on the y. See, that's the beauty of being the teacher. You can change the words. We're going always, because Sienna, it's funny, as I read that, I was like, normally? I don't like normally, because that means there could be exceptions. We're going with always. I'm glad you picked up on that. So guys, let me let you catch up, and then we'll talk a little bit about this idea of independent and dependent variable. Then what we're going to do is we're going to look a little more deeply at scatter plots, a little more deeply at bar graphs. And then we're going to actually look at some data sets and think through how should we process this stuff. And then you'll have a chance to work on your homework. You guys all caught up with me? So, do you remember the little sentence that I had you write down, that the dependent variable depends on the independent variable? Try this on for size. See if this is true. Does the temperature of the water depend on the amount of energy added? Yes. So that means that the temperature is the dependent variable because the temperature depends on the amount of energy. Now flip it around. Does the amount of energy depend upon the temperature? It does not. Therefore, that breaks down. So the sentence that is actually correct, in this case, the temperature depends on energy, tells you the dependent variable, which you immediately put on the y-axis. You get it? Okay, so there you go. So guys, that's line graphs. This one's pretty, I love this example. This is cool. The next one we need to talk about are scatter plots. Guys, scatter plots are kind of like XY line graphs. The difference is there's no cause and effect relationship. So a scatter plot is used when there's a correlation of variables, but it is not cause and effect. Therefore, there is no dependent or independent variable. You could switch them and it would still be fine. So as you're writing this down, let me dim the lights so you can see this better. Actually, I'll zoom into it too. This is a pretty cool example. I got to give credit where it's due. Mr. Maurer shared this with me. Did you guys all have Maurer? You realize we're twins separated at birth? Like 60% of the time we actually wear the same color shirts without meaning to today. He is, I know. And it scares me, you know that, but yes. Oh, you do? Oh, okay, there you go. Yeah, and we don't plan it. We're just both idiots. You guys all caught up with me? Okay, guys, check this out. You ready? This is a pretty cool little graph. Help me make sense of it. Let me just give you a second to look at it. But I'd never thought about this until Maurer shared it with me. And maybe he will, Tatum, with you, because he may use this as well later. So guys, what does this mean? Can anybody interpret the graph for me? Anyone feeling brave? Thoughts? Do you want to go? Yeah. Okay. Okay, so let's talk. So we have down here, and Old Faithful, right? The geyser, Jellystone, Yogi Bear. Yeah, okay. So, guys, we've got the length of the eruption, and then we've got the time between eruptions. So say again what you said. Okay, so hold on. So the longer that you wait for an eruption to take place, the longer that eruption will be. Is that what this graph is saying? Yeah, because look, guys, if we go up the length of the wait, we find out that the longer we wait, the longer the eruption will be, right? But isn't there another way that we could think about this? What about this? The longer the eruption is, the longer it will take for it to erupt again. Which one's right? Both. Which one causes the other? Neither. We don't know. We really don't know. Is it the longer you wait, the longer the eruption, or the longer the eruption, the longer it takes for it to erupt again? And the answer is they are both correct. Because they're both correct, there is no cause and effect relationship, and so consequently we would do this on a scatter plot rather than an XY line graph because it does not have a cause and effect relationship. Do you see the difference? Whereas with our previous example, when you add energy to water, the temperature goes up. One causes the other. Whereas here, there is no cause and effect. You get the idea? That's a good example. I like that. Watch your eyes. Okay, so now we've got to talk about the last one that you need to know, which are bar graphs. So guys, in a bar graph, we are talking about distributions of data. This one I clearly stole from Maurer because it's about black cherry trees. But the idea is this: if you've got a little grove of black cherry trees and you measure their height and then you count how many of them there are, you can then figure out that there aren't very many short black cherry trees, there aren't very many tall black cherry trees, that most black cherry trees are somewhere in the middle at about 75 feet. So when you want to look at trends within populations, you do that using a bar graph. The idea is the taller the bar, the more things are that have that characteristic. Do you get the idea? So guys, those are the three that you have at your disposal, and you'll be using them throughout the year. XY for cause and effect, scatter for relations that aren't cause and effect, and then if you've got distributions of data, then we're going to go line graph. You good? Questions on that? Okay, guys, everything we're going to do for the rest of the day then is going to be application. So here you go. So check this out. I'll turn out the lights again and zoom into it. Guys, here's some data. I'll zoom out in a second, but let's zoom in now. So down the left-hand column, we've got months of the year. Down the center column, we have the average high temperature in Fahrenheit. And down the right-hand column, we have ice cream sales. And actually, I think the units are like it's like thousands of ice cream cones or something like that. But anyway, so guys, say that you're given this data and you want to graph this data and you want to really get at the heart of what this data is all about. So now let's think about it. We've got three choices in terms of how we can graph this data. So what I've done is I've actually generated examples with all of our choices, and let's see which one makes the most sense. So guys, first of all, this one, that makes no sense at all, right? That's not even a choice for us. A pie chart. That doesn't tell us stinking anything, right? That's why we don't do them. So now let's try this. What if we did an XY line chart? Where, guys, on the x-axis, we have temperature, and on the x-axis, we have month, and on the y-axis, we have average high temperature. Is that the point of this data? It really isn't, is it? So what if we try this? What if we try a bar chart? Is that what we're looking for? Maybe closer. Now maybe we've got month and we've got ice cream sales, but I would suggest to you that we're not quite there. Guys, if we really want to represent this data, here's what we need to do. We need to first of all understand that the data that we're looking at is relational. But what is the relationship we're looking at? We're looking at temperature versus ice cream sales. We want to know, how does temperature impact the amount of ice cream somebody will sell? So guys, first thing we need to do is we need to use our axes appropriately. So it goes like this. Ice cream sales we're going to put on the y-axis, and temperature we're going to put on the x-axis. Now guys, let's call a timeout. Did we do that properly given what you know about independent and dependent variables? Which one goes on the y? Let's do it differently. No, let's do it that way. Which one goes on the y-axis? The dependent or independent variable? The dependent. So guys, try the sentence on for size. Does the amount of ice cream sold, does the amount of ice cream sold depend on temperature? Yeah, but what about the other way around? Does the temperature outside depend on the amount of ice cream that's sold? No, because if it did, if Baskin-Robbins is having a good week, it's going to get hot out. Guys, ice cream sales don't change the weather, but weather changes ice cream sales. So ice cream sales do depend on temperature, therefore we've set these up properly. Get the idea? Then guys, we need a title. And so a title might be something like the correlation of ice cream sales and average high temperature in Orem in the year 2013. And then we are going to set up a grid. We are going to plot our points. Then, guys, rather than connect the points, we are going to draw what's called the best fit line. And you probably know that best fit lines, which you'll be drawing a lot in this class, are actually graphical representations of averages. And now let's talk about what this means. As the temperature goes up, what happens to ice cream sales? They go up. Go ahead, Tatum. The line of best fit, so the line of best fit does have to be straight. But the other thing is when we draw them, what we're going to do is this. We're literally going to take a ruler and we're going to eyeball it and just try to split as many of the points as we can. But guys, if you know how to do these on Excel, you can actually get software, computer software, to draw them perfectly. But they always have to be straight. So, you guys okay? You're okay? Okay, so let's see how you do. This is how we're going to wrap up the afternoon. Guys, here's the experiment. You ready? Let me lay out the ground rules for you. And you're going to be writing a fair bit of this down, but you're going to have to be creative in how you take notes. So guys, the experiment is this. We take some plants and we give them varying amounts of fertilizer, and then we come back after a month and we measure how much they grew. Do you understand? So some plants get a little bit of fertilizer. Some plants get a bunch of fertilizer. We measure how much fertilizer we give each of these individual plants, and then we come back a month later and we figure out how much they grew. You get the idea? What's the independent and the dependent variable? So guys, what's the independent variable? What's the dependent variable? Think about it. I don't want to talk about it yet. This is one of the hard parts. Which is which? Fertilizer or plant growth? Which is which? Give you a second to think about it. So fertilizer and plant growth, which is going to be which? So Rachel, what do you think? Which is which? Good, and? It's dependent. So Rachel's saying dependent is plant growth, independent is fertilizer. Let's see if that fits with our sentence. You ready? Plant growth depends on the amount of fertilizer. True? The amount of fertilizer depends on plant growth. Not true. So you did it right. Plant growth depends on fertilizer. Now guys, which goes where? Which goes where? Which goes on X, which goes on Y? Go ahead. Yeah.
Plant growth goes on X.
Okay, so the dependent plant growth goes on the X, the independent fertilizer goes on the Y. Oh, we did that backwards, crap. So dependent plant growth goes on the Y, and then the independent fertilizer goes on the X. Is that better? Woo, thank you for catching me. Okay, so guys, with that done, you ready to graph some data? And I'll try to cue you into the things you want to write down. So it goes like this. You ready? Here's some data. The data is over here on the left, and the data gives us masses of fertilizer in grams, plant growth in centimeters, and we did about a dozen different plants. Then on the right, obviously, we've got our graph paper, right? So this is what your homework's going to look like. I'm going to give you data and you're going to have to graph it. So let's start fundamentally. If we've got this kind of data and if we understand the experiment, what kind of graph are you going to choose? Bar graph, XY line, or scatter plot? Let's think. Bar graph, is that a good choice? Is this a distribution in a population? No. Now let's talk about our other choices. Scatter plot, we do not use for cause and effect. XY is used for cause and effect. Is there a cause and effect relationship between the amount of fertilizer and the height of the plant? Yes. So if it's cause and effect, what are we going to choose? Line graph, right? Okay, so we will choose a line graph. Now, again, guys, there's gonna be so much stuff coming up on the screen right here. I will cue you to the things you need to put in your notes. So we're gonna start graphing this data. Don't write it down unless I cue you. You ready? So the first thing that we need to do, and this you do need to write down, guys, when you're drawing your graphs, do not start your axes at 0 unless 0 is a part of your data. So there are no 0 grams, there's no 0 growth, so we will not start at 0. These are rules that you need to know about graphing in a chemistry class. Do not start at 0 unless it's a part of your data. Okay? Thought number 2 is this. Guys, see it down at the bottom? Always make your graphs larger than half the page. That is always going to be the case. And by the way, guys, we should probably mention this too. Always draw your graphs landscape orientation. Do you know what that means? So this is portrait, this is landscape. You'll always do your graphs landscape. Yep, turn them sideways. Yep, you got it. Are you guys all caught up with me? Okay, so I don't know if you need to put this in your notes necessarily, but one of the things that you've always got to do in your graph is put a title. So you may just want to write something about always put a title. The title that I chose for this graph is the effective fertilizer amount on plant growth. Because you've always got to put a title on your graph. Now, we've already had this conversation, but maybe we should make it a note point. But guys, what we're going to do now, once we've titled the graph, is we're going to label our axes. So this we decided was plant growth. Notice there's units. Then down here on the x-axis, it's fertilizer in grams. So maybe your note point should be label your axes with units. These are the things that you're going to be held accountable for when you draw graphs. So far we've said this. Don't start at 0. Make your graphs bigger than half the page. Put a title on them. Label your axes and include units. You okay? So now, guys, this. Now we've got to figure out what each one of these little numbers, what each one of these little boxes represents. We've got to put units on our axes. We've got to put a scale on our axes. Now, guys, here's how to do it. I'll tell you when to write this down. Don't do it yet. Here's the way you identify your scale. First thing that you do is count the number of squares. Okay? This is 21 squares. The next thing that you're going to do is you are going to find the range in your data. So for fertilizer, the low is 2 and the high is 12, and that's a range of 10 from 2 to 12. You good? This you want to write down. Now here's what you're going to do. This equation, just write this part of it down. Range divided by number of squares. That gives you your scale. So guys, all that you've written down is this. Range divided by number of squares. You got that? You don't need to write down this specific example, but write down range divided by number of squares. And then guys, next to it, write this down. Always round up. Always round up. You ready? So check this out. So we said 21 squares. This goes from 2 to 12. That's 10. 10 divided by 21 is 0.47. So I'm going to round that up to 0.5. So now when I label my axes, notice I didn't start at 0. I started at 2. And I'm going to go 2, 2.5, 3, because remember I rounded 0.47 up to 0.5. So 2, 2.53, 3.54, 4.55, and so on. So every one of these lines represents 0.5, and I started at 2. Questions? Now let's do that on the y-axis. So guys, 15 squares, and then our range goes from 18 to 98, so that's 80. So again, when we do the math, we've got Range divided by squares, that's 80 divided by 15, that works out to 5.33. What are we going to do with 5.33? Round up. But guys, it's going to be a wild pain in the butt to round up to 6. Can you imagine that? If you went 6, 12, 18, 24, 30, 36, 42, 48, imagine trying to plot these points when every line is equal to 6. That's really not going to be much fun. So when you round up, you want to intelligently round up to a number that's easy to work with. So 7's no better than 6. What are we going to round that up to? 10. Now we've got units that make sense. But guys, notice that we don't want to round up to like 20, because if we rounded up to 20, then our graph would only come up to here and it wouldn't be half the piece of paper. You know what I'm saying? So we don't want to round up so much that our graph gets too small, but we want to round to numbers that are easy to work with. Well, rounding to 5 would be rounding down. And if you rounded down, what would happen is you would go off the scale of the graph. Yeah, that's a great question. If you round down, you run out of room. So you've got to round up. You get the idea, guys? Okay, so now what do? Once you've done that, what you will do is you will plot all of your points like so. You'll lay all of these points into the graph. And once you have them all in the graph, you will either draw a best fit line or you will connect the dots depending on what the instructions say. And there's your graph. Yep. Mm-hmm. Perfect. The only difference between this and a scatter plot is that you can't switch the axes. Okay? If you were doing a scatter plot, it wouldn't matter which goes on which because there is no cause and effect relationship. The other difference could be this. In a scatter plot, you will never connect the dots. In an XY line graph, you'll be instructed whether to connect the dots or not. Okay? Are you guys, oh, that's a wonderful observation. That's really cool you saw that. So guys, you get the idea? Okay. So if you understand all of that, guys, error check this train wreck. I get stuff like this every year. I'll get stuff even in homework next time on Thursday. If I had given you that same data, this is the kind of malarkey that I would get. So guys, take a look at this from a distance and find all the mistakes. There's a bunch. And then we'll talk about them. So let's talk about them. What do you see? Go ahead.
So, give us a bunch.
Just give us two. Don't pick all the fruit.
The variables are on the wrong axis.
Good. These are backwards. What you were saying, remember we said that the plant height is the dependent variable, so these are switched. What else?
And they're missing a spot on the bottom scale. 13.
Yes. Guys, when you're spreading out your scale, it's got to be even units. If this represents 2 and this represents 2, that can't represent 4. They've got to be evenly spaced units. Please. There's no units like grams on the fertilizer. And this is not a good enough scale. What else do you notice? Other things? Tatum. I'm sorry. Yeah, the title's not descriptive. What else do you see? They didn't plot all their points. Good, bad, or indifferent, they didn't plot all the points. Do you guys see any? I think you've done pretty well. Do you see anything else? So I've actually got them on here. So we need a more descriptive title, as Tatum pointed out. They've got the X and Y axis backwards. There are no units on the fertilizer. These are non-linear. They don't change by the same amount. And this is just ridiculous. There are no units at all. So guys, all of those are things to avoid. You get the idea? So, hey, this is awesome. You've actually got... Guys, have you noticed that for the first couple days in this class, we've been working up until the bell rings? That is normally not the way class will work. I really try to reserve some time in class for you to work on your homework. It's just, remember, we had an assembly, and then we had some other actually the first day was just because it was the first day. But anyway, guys, this is the way this should work. We got 20 minutes, and that's wonderful because it gives you a chance to work on your homework. So guys, let me do this, and then we'll get you going. So the homework goes like this. Let me get it in your hands, and then we'll talk. I like your necklace. You didn't make that, did you? That's really cool. So you're doing biology this year too? Oh, AP biology. How many people are in there? Could you guess? Is it pretty full? No? Yeah. Oh, okay. So guys, read over the instructions with me. This is going to sound exactly like what we just did in class. Graph the following sets of data, keeping these things in mind. First of all, choose the most appropriate type of graph and justify your choice with a sentence. Then, proper graphing principles. Evenly spaced units, title on the graph and axes, don't forget units. Graph larger than half the sheet of the paper. Keep track of your independent and dependent variables. So guys, you've got 3 sets of data there. I will put the answers on the wall in just a second. Miss Call brought me my rulers back. So if you would like a ruler, I will leave that here. I'm just going to spread out some graph paper throughout your rows. You're going to, of course, need 3 pieces plus the extra that you need when you screw up. So guys, there's plenty of graph paper here. If we run out, over there in the bins up above the tape is more. So if I didn't get you enough for everyone to have 3, please come and help yourself to more. If I gave you too much, you can put the extra in the back of your notebook because you're going to need it eventually. But guys, the rest of the time is yours to work on homework. I would love to come and help if you want to talk about any of this. Feel free to work productively with each other, and the rest of the time's yours.